This meeting is being recorded.
Hello, this is Jyoti Dodia and welcome to the 91st session of the PowerVug technical webinar series. You may have realized or been notified that there is a new home for the PowerVug information, and I have posted lots of information via Twitter, LinkedIn and via email if you're on my subscriber list as to where the new home is. The short link stays the same, so ibm.biz/PowerVug. So today's session, I'm really pleased to have Sean Greaves, who's in our AI team in IBM, present the art of the possible with PowerAI Vision. So he'll be giving you lots of interesting examples of how you can use PowerAI Vision to help with some AI-related aspects, what you can actually achieve in a short space of time. So without further ado, let me hand over to Sean.
Jyoti. Hi everyone. So thank you very much for joining. It's super cool seeing all the wide array of places everyone is joining from. So I'm Sean. I'm a client technical specialist in the Systems AI team here in the UK. I'm based out of London South Bank office. And my focus in IBM is all around the Watson machine learning portfolio. So the artist formerly known as PowerAI. So taking that technology, understanding a client's problems, and knitting the two together. So other than focusing on the technical side of things, I have a real interest in how we promote our offerings and communicate and do marketing. So my role also involves running meetups. So I run the IBM AI London meetup series, and also very interested in blogging about what we're doing and finding all the kinds of creative ways we can to promote our AI technology. So I've only been with IBM for a year, so prior to that I was living and working in Berlin as a creative technologist. So that's just a little bit background about me. So in this session, I'm going to be running through some of the latest and greatest additions to PowerAI Vision. And I'm going to cover some of the success we've seen in the UK with PowerAI Vision, discuss who is currently using it right now. And then finally, I'm going to wrap up with speaking about how we create demos and experiences with PowerAI Vision to kind of bring it to life for our clients and for people who are interested. You may also be wondering why I'm sharing a picture of mushrooms. So recently I was presenting in a biology lab at university. So it's just the flavor of the month. It could be cars, buildings, next, who knows. So first up, I thought I'd talk about computer vision. I realized the last talk we had in this community around PowerAI Vision was back in March last year, and there's been a lot happening in the field, of course, since then. PowerAI Vision is built on all this open source innovation we're seeing in the field, so it's perhaps the best place to start to discuss what's been happening over the last year in computer vision. So when I'm talking about computer vision, I'm going to focus on deep learning. So by deep learning, as a reminder for those who aren't looking at AI every day, it's the application of neural networks for computer vision. So by neural networks, we are referring to general purpose functions that we train to recognize statistical regularities in our data. So if we're working with images, we use neural nets to identify features in the data, like objects and things. So traditional computer vision is quite a time-consuming, iterative process. It requires us to articulate what we're looking for in some detail. So the main process in traditional computer vision would be feature extraction. And this requires the engineer to define what we're looking for based on edges, corners, color gradients. And the engineer has to choose which features to look for in an image and which features best describe the object they're trying to detect or look for. So for deep learning, our approach is different with using neural networks because we are training a neural network to work out what the most descriptive and salient features are within an image, rather than us defining this. So with neural networks, we of course only define what images we're passing through the network during our training, in addition to what our network deciding what the network architecture is, what is best suited to our use case, and how we will conduct the training. So this year, we've seen, so since 2012, we've had a lot of different studies come out where we've applied deep learning to image use cases. And we can now kind of look back at these studies and see how we've been doing and kind of assess the performance of deep learning approaches to analyzing images. So with regards to medical imaging, researchers from University Hospital Birmingham, NHS Foundation Trust recently conducted a review of published research since 2012 on the use of AI for diagnoses within medical images. And based on 14 published studies, they found that the performance of deep learning approaches was on par with humans in the cases where we're using deep learning to diagnose based on medical images. So in the research they looked at, deep learning systems were able to correctly identify disease 87% of the time, whilst healthcare professionals managed to do this 86% of the time. Additionally, deep learning systems correctly sent people home with all clear 93% of the time, compared to humans, which had managed to do this 91% of the time. So this is positive, I think, because we're kind of cutting through a lot of the hype around deep learning systems, this hype around them vastly outperforming humans or making radiologists redundant or something like that. And we're moving more towards AI being tested in clinical trials in a robust way that allows us to properly assess how the technology could be used to augment our current workflows. And there really is a vital demand for this. The amount of imaging really outstrips the supply of radiologists. And in addressing this, the government has recently just announced 250 million of funding for a new NHS AI lab. So however, whilst we can train neural networks to identify objects of interest within our images to a very high degree of accuracy now, we may be left wondering what the network has actually captured or learned from our data. After all, in traditional computer vision, we are kind of specifying ourselves what we should be, what we're looking for, and how we are classifying our images. And we aren't really seeing anything other than the network's classification result. So for a very interesting and visual bit of explainability around this, we can take a look at a different approach to deep learning. So we can look at what we call generative adversarial networks, otherwise known as GANs. And GANs are used to generate new data as opposed to classifying data. And using GANs, we can basically kind of comprehend the, quite frankly, astonishing level of detail that deep learning approaches are capable of capturing. So recently, NVIDIA published a paper where they described using GANs to generate new faces. So in these 4 images here, you will recognize one of the faces is a real living person. The other 3 faces are completely generated. They're people that don't exist. And I like using this image with people who aren't IBMers, if I'm talking in a school or outside of IBM, and trying to make people guess who the one real person is out of the 4. Because the point being that the network, this deep learning approach, has been able to capture such an incredible level of detail in our data, such that we can't tell the difference between synthetic data and real data. And this is a really interesting approach, and we actually had a researcher recently talking at one of the IBM AI London meetups around this. So Matthias Treder is a researcher at Cardiff University, and he's been using this approach in medical imaging to generate new pictures of lungs that could be used to could be used in training further deep learning models to kind of address issues of data privacy, because in many cases you are quite restricted in how you can use patients' data, and perhaps creating synthetic data which can't be traced back to individual patients could be quite a promising way forward in applying deep learning to medical imaging. But we've also seen a lot of progress this year around addressing the quality of the data that we're using to train our systems. So at the start of the year, IBM open sourced a large and diverse data set of 1 million annotated human faces. And this was an important step in making sure that we are working with data sets that represent the diverse people that will be interacting with these AI systems. So this particular data set was addressing the poor performance of facial recognition technologies for different groups of people, and it was a very kind of a very important, useful data set to release. And I think we're seeing this year as well a kind of rejuvenated kind of sense of being critical of the data that we have been using to train many of our systems. So this picture I've got here is a picture of an exhibition around Imagenet, which is perhaps one of the most famous image data sets out there. It was compiled by researchers at Stanford University in 2009. It contains 14 million images and is sorted into 21,000 classes. Many of these classes are what you would imagine in a large image data set. So there's classes for trees, fruit, like strawberries, oranges, cars, things like that. But there's also more troubling classifications of labels for this data. So you'll also find images that have been labeled under classifiers such as failure, loser, non-starter, and unsuccessful person. There's also some much more questionable classifications that I won't mention here that are quite disturbing, considering that this data set is then used to train many of the visual recognition systems that we currently might be using. So this issue around the data that we're working with to train AI systems being labeled in a poor way or a questionable kind of way reiterates the importance around making sure that role is placed in the hands of the person who is most competent to do that task. So the subject matter expert who knows the data best and understands the nuances of the use case that we're designing our AI system for. And this is really a core focus and has always been a core focus of PowerAI Vision, the tool that we've developed to place the role of building a computer vision model into the hands of a subject matter expert, such that it is the subject matter expert who is labeling the data, building the model, training the model, and then able to evaluate it alongside other members of the data science team. So yes.
Let me just tell people that if they wish to ask questions or make any comments, suggestions, please do so via the chat window. If you click on the blue bubble tab and icon, then you will be able to get to the chat window. So I'll monitor for that. And also to inform people, you mentioned last year's session in March that was run around PowerAI Vision. I've posted a link to the chat window with the details of where people can get hold of last year's session. So replay for that is available as well. So session number 72 on the Power info. Thanks.
Thanks, Jyoti. Yeah, forgot to mention that. Ask any questions in the chat at any point, and I can try and answer them. So yeah, as I'm kind of showing in the slide here, we are extending the role of the subject matter expert in this case to prepare our data, building models and training them. And the goal, the effect of doing this are we can free up some of the data scientist time to focus more on evaluating the models that we're using. We're also creating models that we can deploy in a very very simplistic way that can be easily consumed by our software developers to be integrated into applications, as we'll demonstrate a little bit later. And we've got a lot of options for where we can deploy these models that we're creating, whether that be on one of our servers or FPGA cards or even iPhones as well. So at this point, PowerAI Vision only runs on Power. However, the PowerAI Vision inference server, so the tool where we create our pipeline around our model, that can be deployed on x86 as well as Power. So the last time you saw PowerAI Vision, it probably looked quite different to what it looks like now. It's had a very snazzy visual redesign, thanks to the nice people in the Austin Design Studio. It's now all looks like all of the products that have been kind of reworked using our IBM Carbon design framework. So it looks really great. PowerAI Vision is still the tool for building custom computer vision models with your own data to detect whatever you're wanting to detect in your data. It's not the tool for doing more horizontal solutions, such as standard tasks like person detection of common objects. It's really for building models with your own data for your own specific use case. We've got, so the steps to building a model are very simple, and there are key features in PowerAI Vision for reducing the amount of time to build a model. So we have the capability of using base models for training new models. So if you have models that are already trained, you can use these as a starting point when training a new model. And this allows you to train faster and also create a more accurate model. There's also the life-saving capability of auto-labeling. So when you have to label an enormous data set, it can take a lot of time. It's fun for about 5 minutes, 10 minutes, and then it can become mind-numbing. So with auto-labeling, you can train an initial model based on a subset of your data that's been correctly labeled, and then that model can be used to label the rest of your data set. So this can save you a lot of time, especially when you've got thousands of images to label. So I'm just going to now jump into the interface for PowerAI Vision and discuss some of the latest changes that we're seeing here. So I'm going to stop sharing my PowerPoint and start sharing my web browser.
While Sean's doing that, I was just wondering if anyone has come across PowerAI Vision, whether you've used it or seen demos of it or are planning to use it. Just let us know via the chat window.
Is my browser sharing now, Jyoti?
I can see you're sharing something. It looks like the browser, but it looks very similar to the slide you were showing earlier. So just click.
Get started. Can we see?
Yes, it is working fine.
Great. Okay, so PowerAI Vision is great for essentially chucking our data into the tool and getting started with labeling and training a model. By chucking the data in it, I really do mean that. You have 24 gigabyte max size per upload, so you can throw a load of images in there, and then once that's uploaded, another 24 gigabytes, and keep going. With the kinds of data we can work with in PowerAI Vision, we can work with images, and we can also work with video data. So to speak about images first, standard formats like JPEG, PNG. However, a useful thing to bear in mind is that when we are uploading images into PowerAI Vision, depending on what model we are training with, those models, each of them will be resizing our images prior to training. So this is an aspect of the data preparation that we aren't doing. The tool automatically does this, but it's something to bear in mind depending on what your use case is. For instance, if you're wanting to train a model for image classification, your images are going to be resized in PowerAI Vision from whatever size you've uploaded them in as to 224 by 224 pixels. So if you have got if you're trying to do image classification with very large images to classify based on very small features in the images, it may be that you're going to struggle to do that by this approach because of the image resizing. So it's just something to bear in mind that you may have to consider another approach, or you may have to upload a different model into PowerAI Vision because you have the option of uploading custom models as well. So one nice additional kind of image we can upload into PowerAI Vision is a recent addition is DICOM images. So DICOM images are essentially images used in essentially medical images. So they're not like super fancy or anything. They are essentially just an image with some metadata attached. That metadata could be around your patient, such as the patient ID, name, sex, whatever. But when you upload DICOM images into PowerAI Vision, it's just like uploading any other image. It just comes in as an image. So nothing too fancy happening here. But one of the very cool capabilities we can now do with PowerAI Vision is uploading video data and working with that. So I've got an example here uploaded, and this is a football match. And you have various ways or various things you can do with this data. So if you've uploaded a video into PowerAI Vision, you could do object detection with that video. So with object detection, what we are doing is we're looking at each of the individual frames in the video, and we're labeling certain objects. And this is a model that is based on still images. So we're not looking at something happening over time. We're not looking at some kind of temporal process. It is looking at each image, and we're detecting objects in them. And it's very useful to be able to do this because we can then use auto labeling to basically label an entire video. And if we've got a video with absolutely loads of frames in it, this can really speed up our workflow in doing this. But if we're wanting to label or detect temporal processes, so an action happening in the video, then we have the capability now to do that as well. So the difference between detecting an object and detecting an action we experienced recently in the team in trying to build a model that recognizes the letters in the American Sign Language alphabet. So when you're training a model to do something like this, you can train an object detection model to recognize most of the letters in the American Sign Language alphabet. So most of these letters can simply be described with a photograph. However, there is one letter that requires an actual motion to do. And so you would struggle to describe this letter using object detection. And this is where you would need to take an action recognition approach, because you have some kind of directional process that has a starting point and an end point. So for labeling, for training action recognition models, PowerAI Vision now has an approach to doing this integrated into the tool. So we are using structured segment networks to train to recognize action. This is a framework devised by researchers at ETH Zurich and the Chinese University of Hong Kong. It's got a lot of application in surveillance and video analytics, but also sports as well. So some of the first demonstrations of this in action in PowerAI Vision involved training a model to recognize golf swings or tennis shots, things like that. And one member of my team has recently built a POC for a company that's doing sports analytics around action recognition.
Sure.
Yes.
So question, can we give live video stream to IBM PowerAI Vision?
That is something that is not built into the tool currently. But that said, I'm wondering if it's something that you could build around it. I haven't actually done this with action recognition yet. We've done examples where we have done real-time object detection based on video from webcam feed. So it could be video feed from anywhere. And that basically required us to training the model PowerAI Vision and then deploying it using PowerAI Vision inference server on one of our servers, and then doing inference that way. But I don't know if we can do it live using action recognition. I'm not sure yet around network latency or the time that it takes the model to infer whether we can do that. But you can do that with the other models like object detection. So if you're looking to do live object detection, that's something you can absolutely do. You can't do it with necessarily in the PowerAI Vision tool, but you could easily deploy that model and use it within an application to do that. And I'll show an example later of us doing that.
So I guess it's worth reminding people, if they're new to this, that there are two kind of parts to this. There's the building the model, so training your system based on things that you already know, either images that you already know have got, cancer cells or whatever it is, or training it with this video where you might be recognizing advertising boards. So something that you already know, you train it, build the model, and then you can deploy that and use it against data it has never seen before, i.e. the inference side. So they're two different parts, as I understand it.
Yes, that's absolutely right. And PowerAI Vision at first was really focused on the training side of it. So chucking your data into the tool, labeling that data, training a model, and then being able to test the model in the tool. So much of what I'm discussing here, or going to discuss, is more focused around deployment options. So having more options of where you deploy those models, and also inference, how we speed up our inference, particularly in cases where we're wanting to use that model in real time, because it's not necessarily a trivial thing. It's quite challenging for some models to do that. So in this example here, I'll just demonstrate how we label actions. So to label an action in a video, all we have to do is specify a start time and an end time for that action. So action recognition is actually a really challenging task. And the model that we're using is really state of the art in that it's not only able to kind of detect an action, but it's also able to discriminate on whether or not that action is completed. So it's all fine and well if you're detecting a kick that you've detected where someone's kind of lifted their leg back in preparation to kick, but you only really want to classify a kick when the player has connected with the ball and the ball is actually in movement, and you've transferred that momentum. So that's something that is really important that we need to do here. So we need to specify a start time and an end time for our action. So the player I've got here is just started walking. So I can find where in the video he started walking. So I'd say about here. So I'll specify this as the start time. I will then let him continue walking, and then he's kind of stopped. So I will then specify an end time, and I will label this action as walking. So you may have noticed here that there may be a problem in doing this, in that I've got multiple players in this shot, all walking and running. And this is a problem you will face with action recognition, that you want to kind of really make sure that you've got really one subject. If you're doing something like labeling walking or labeling kicking, that you've got kind of one subject in the photo with strong directional motion, such that you're kind of really training the network to recognize that particular action. So it makes it very kind of effective if you're doing things like detecting a golf swing, because in most of the shots, if you're looking at downswing, you've only really got one person in the shot. But it could be quite challenging in other cases where you've got lots of players kind of running around, like a football match or something like that. So that's action recognition. However, most of the time, probably the most common use case we face is around detecting objects and images. And PowerAI Vision now has capabilities to do this in a much more localized and focused way. So what I mean by this is, so I've got an example here of a data set of chocolate bars. I can now, so I could label this chocolate bar here for training using a bounding box, but we also now have the capabilities to do this using complex polygons. So we can be far more localized and focused in how we label our objects. And this is a really neat capability, especially if you are trying to label objects that are diagonal or a bit more complex. And when we're doing this, we are labeling this data set so that we can train it using the very ominously titled Detectron network, a Detectron model. So Detectron is the model we use to perform this task where we are identifying complex shapes in images. It's not a killer robot. It's actually Facebook AI Research's software system for doing state-of-the-art object detection research. So when we say that we are integrating the best of open source into PowerAI Vision, in this example here, we are integrating some of Facebook AI's frameworks to do effective image segmentation tasks. So image segmentation is essentially object detection, but more localized in our detection. The particular model that we're using in this case is a mask RCNN model. That sounds horrible, but it's pretty descriptive. So the mask is what we call the highlighted area that we are segmenting in the image. So the complex polygon that we have labeled. And the RCNN is essentially the object detection part of the network. So that's essentially what we are doing with this network when we see an image. Is we are detecting an object first of all. We are highlighting, creating a kind of box around the object for where it is, and then we are developing this more complex mask around the object to highlight it against its the background. So this model only really runs on GPU, and it will take longer to train than just doing an object detection model where we are labeling boxes and images. Because we have this additional branch in our network that's focused on generating a mask around the object that we're looking for. However, you don't need a GPU to deploy all of these models onto. Many of these models are built more to be lighter on memory. They're not as accurate in how they label or identify, but they're lighter on memory and they're faster on inference. So by inference, we mean faster in being able to classify images. And as a result, they are suitable for deployment on and mobile devices or FPGA cards. So an example of a model that you could deploy onto a device like an iOS or FPGA is this wonderfully named Tiny YOLO model here. So what do we mean by Tiny YOLO? So it's tiny because it's much smaller than the other YOLO model that it's derived from. The YOLO model that it's derived from has 3 times more layers in the network than Tiny YOLO does. YOLO stands for you only look once, and it's called this because to do inference, it's taking a slightly different approach to other networks, such as the RCNN network in the previous image segmentation example I mentioned. So with RCNNs, our network is required to do thousands of evaluations before a final output can be generated. But with YOLO models, we are applying a single neural network to a whole image, and it only makes a single network evaluation as opposed to thousands. So as a result, it is 100 times faster than RCNN network. And if it is on a GPU, it can run at 200 frames per second. So a model like this would be very useful for doing real-time inference. And you could deploy this onto an iOS device. You wouldn't need network connectivity. It would just sit on the device and do and classify images from the device. But we do run into the problem of how we actually get those models onto a device. So, for instance, an iOS. There are lots of models currently on on an iPhone if you've got one. particularly with in how we use the camera on the iOS. So there's models that do facial recognition, scene detection, person detection, and the way that these models are packaged up to exist on the iOS is using a tool called or a framework called Core ML. So if I go into the training options here, I've got for Tiny YOLO, I've got the option of enabling Core ML. So Core ML is the framework for bringing machine learning models onto Apple devices. And we would want to do this because there's many cases where we don't want to have to constantly be communicating with our server to get for inference. We could be dealing with high latency, rubbish internet connection, or privacy. We might not want the data to leave our phones. So CoreML is the framework we use to do this. I'm just going to try now and navigate out of PowerAI Vision and share instead my presentation. So if you just bear with me 1 second.
Reminder that if you have any questions, put them into the chat window.
Okay, can everybody see my slide?
Yes.
Great. Okay, so with CoreML, we have some nice tricks for reducing the size of our networks to make them able to be stored on an iOS device. So one of these techniques is called quantization. And this is a technique whereby we are trimming the number of bits used to describe our model, in the model weights. And we do this in quite a simple way, really. We are converting the float values or double values used to describe our model weights into integers. So 5.9 to 6 or whatever. And by doing this, we can reduce our model size by up to 4 times. And this becomes really effective when we've got a model that has several million weights. So there's an example here I've got where we've got a model and we've got different examples here where we have we've quantized the model, we've reduced the size of the model, and we are still seeing inference that is of good quality. So this particular model here is a style transfer one. We're taking this image here of a very nice house and kind of transposing the style of some kind of artist onto that image. And we're seeing here that we can reduce our model by up to 4 times, and we're still getting really decent results. So this is a really nice capability to ensure that we are not kind of doing overkill by taking a large model, storing it on our iOS device, and we are able to kind of have more to keep more memory and make sure people don't have to download some huge application, which in many cases they would not want to do. There's also other tools in CoreML for reducing model size. So one of them is also model pruning, which is a lovely metaphor. This idea of some kind of AI gardener kind of snipping off all the wilting branches off some large rooted structure. But model pruning is a technique whereby we test model weights to find which ones have kind of negligible impact on our model's output, and we remove them.
Sean, there's a question.
Yes.
And comment. So regarding auto label, it is a nice feature, but Marvin is wondering if you can put any bias you have in your trained data to the new auto labeled data. And then as an additional thing, the integration of a threshold makes sense, but wouldn't it be even better to give a low confidence images back to the user to manually relabel?
Yes, so good question. So the first question, this question is more around, is it a concern that bias in the in how you've labeled the original data will be replicated in the auto labeling? If I understand,
I would read it as that.
Yes,
I believe that's what they're saying. Yes.
Yes. So absolutely, that is a worry, and in many cases, that's something that you would want to really address that you would you would need to be very cautious of in auto-labeling. So a good example of auto-labeling of a task that was really suited to it was when several members of my team trained that model to recognize letters in the sign language alphabet. So what they did was to use auto-labeling to label all of the lots of hands in images. All of their images were essentially the same format. It was a single person in an image holding their hand up to the camera. And it was essentially they wanted to first identify the hand, and then that would be the first task, and then they would then go on to identify the letter that each hand was signing. So in this case, there's not really any kind of negative consequences or bias here when they are simply just trying to identify hands in an image that has a very regular format. But I agree that there's definitely other cases where you would want to be very careful about using auto-labeling to replicate bias. And then the second question, could you just remind me what the second question was? I don't have access to the chat.
Sure. The integration of a threshold makes sense, but wouldn't it be even better to give low confidence images back to the user to manually relabel?
Yes, that's a very good point. That's currently something not in the UI, but that's actually something that people have been integrating into their own kind of applications with PowerAI Vision models as a backend. So I'll discuss an example later that I think touches on that.
Great, thank you.
Great. So moving on from CoreML, CoreML has recently been integrated into, or CoreML models allows us to move PowerAI Vision models onto iOS. So we've recently released IBM Visual Inspector, which is a tool for taking models out of PowerAI Vision, CoreML enabled models, and accessing them on our device. So I've got an example of that application running on my iPhone here, which I downloaded last night. So the application has currently got two models in it for testing. So one is a model that you can use to identify different kinds of Arduino. This is very handy because I love Arduino. I've got quite a few around my house at the moment. So I tested it just to see how well it could classify my Arduino Mega. And it's interesting because the dataset is trained on some kind of other kind of Arduino that's black in color, but it was still able to kind of quite confidently identify the Mega based on its shape. The Arduino Uno, it didn't manage so well. But it's a nice illustration of how you can kind of scale up these models now, and you could have them on so many iOS devices, and I think it really kind of opens up the different use cases you might have. So just a little bit now on where we've been seeing PowerAI Vision being used in the UK, where we've had success with it. PowerAI Vision is currently being used in the Advanced Manufacturing Research Centre in Sheffield. So this is a high-value manufacturing centre that was launched by UK Innovate, and it brings together researchers from Sheffield University with various industry leaders and startups to move various kind of Industry 4.0 prototypes into production. So the centre isn't just focused on AI, it's also got lots of IoT and robotics going on, but they've recently been using AI Vision for visual inspection for structural components. Unfortunately, I can't be any more specific than that because it's a very recent project that we've initiated. They currently have AC922 that they're running this on their premise. But hopefully we'll get some details soon so we can be a bit more specific about the really interesting use cases that they're working with. We've also continued to collaborate with a company called Oxford Cancer Biomarkers. So Oxford Cancer Biomarkers, they identify biomarkers in microscopic images of tumors to diagnose early and provide personalized care. So what I mean by looking at images of tumors is they are trying to predict which patients who have stage 2 colon cancer require further treatment following surgery. So someone's had surgery and we're trying to assess now whether or not they should have chemotherapy, whether or not that will be an effective course of action. So chemotherapy is in many cases over-treatment for people who've had this kind of surgery. Only 33% of those identified with stage 2 tumors will require chemo. And if we can, we really do want to avoid treating with chemo. There is, of course, a risk to life, being exposed to that toxicity. 20–30% of those of these patients who go through chemo experience severe side effects. So there is a huge incentive to be able to detect these biomarkers that can indicate whether or not chemotherapy will be effective. It could save thousands of lives and potentially billions of dollars through reducing unnecessary overtreatment. So prior to IBM being involved with Oxford Cancer Biomarkers, their workflow for making a prediction based on some tissue involved labeling cell nuclei within using a microscope. And this was a laborious and frustrating process. You'll hear this if you ever manage to catch the head of R&D giving a talk. He loathed this microscope. It basically rattled every time somebody walked past or a train went by, and made the whole process essentially take months for them to arrive at a prediction based on a tissue sample. So instead, what they were able to do with PowerAI Vision was they could train a model to recognize the types of cell they're looking for. And they could, instead of using a microscope, they could scan all of their slides into the computer and then use that AI vision model to label the slides for them. And then they could be the second reader in this case, and they'd have very quick access to all these labeled images, and they could arrive at a decision in hours as opposed to months. And as a result of this, the product has been that they've built with PowerAI Vision has been clinically validated in around 1,000 stage 2 colorectal cancer patients. And they've recently also won a bid for a partnership project with Warwickshire NHS Trust and University Hospital Coventry, with the output of this being the launch of 5 new centres for excellence in digital pathology and imaging. So this is a really fantastic use case and a clear use case for using PowerAI Vision to accelerate their workflow. So I want to conclude this talk by kind of discussing the different demos and experiences our team's built around PowerAI Vision. So much of our role involves going out to clients and demonstrating the technology, as well as going to conferences and trying to kind of lure people in to speak to them about what we can do. So there's often a lot of models from PowerAI Vision get shared on social media, and people showing just what it can do. I think the best one I've seen on social media was PowerAI Vision to detect sharks using a drone in this case. I love this use case. My younger brother recently moved to Melbourne and has taken up surfing. So it's a fantastic use case, and it would be nice knowing that drones and AI are keeping him safe from the sharks. So a lot of the times when we go to clients, we understand the use cases are in many ways quite similar. So we often try to find kind of tactile, simple ways of demonstrating how we could address those use cases with PowerAI Vision. So one of the ones we've seen recently is in manufacturing, involves parts on assembly lines and being able to detect that we have all of the parts required to assemble something. So recently we were visiting an automotive manufacturer who were describing to us their how frustrating it was for them with parts on assembly lines, and when they essentially have all their parts contained in a box and they put them on the assembly line, and there are times when one of the parts is missing, and this essentially holds up the entire process and costs them quite a bit of money. So what we wanted to do was to demonstrate using PowerAI Vision to be able to detect all parts are present before we assemble a vehicle. So to do this, one of my colleagues was currently at the time building Lego cars with his kid. So this provided an excellent example of how we can use AI to demonstrate this. So again, through the interface, we get a lot of nice explainability around how accurately we're detecting our models, and it allows clients to really visualize how this could scale up to their use case, even if it is kind of playful and tactile. Of course, pop culture is a great place to mine for image data or video data to test our models for. I love this example with Mr. Bean. it's perhaps a slightly controversial use case. I wouldn't show this to every client because it is detecting guns. It's using quite a light-hearted video to do this and doing it quite effectively. It's also showing misclassification. It just classified that guy's tie as a gun. And it's, I think, important to demonstrate that whilst we can train a model, there are often times where that model will be quite inaccurate and maybe seeing guns in random bits of furniture or architecture. And it's important to kind of, I think, demonstrate the thing in motion to show them just how accurate it is and what AI will actually do. There has been time, and so actually I forgot about this example. So I mentioned the model that we trained to classify different letters of the American Sign Language alphabet. It was a very useful model for kind of getting people interested in how you could use AI perhaps to help those who are unable to hear. So this model alone kind of generated so much interest that there's been different charities who've been kind of doing design thinking with and exploring how it could be used. But it also allows you to kind of, I suppose, be a bit more customized in your approach to demonstrating the model. So recently I was up in Glasgow, not recently, back in the summer, and you could use this model as a way of demonstrating how you could spell the location you're visiting, which I thought could be quite a nice touch. But as you can see, the demonstration I've got here is running on this kind of hacky looking window, and you can see the terminal in the background. It doesn't look very good, and there's many cases where we want to offer more of an experience and help clients imagine how they could see these models being integrated into some kind of application. So that's something we've recently been kind of exploring. So we've basically used different frameworks like Flask and Node.js to build different applications where we are deploying our models on our server and then kind of designing a very basic web interface to interact with those models and to allow clients to imagine how they could train models in AI vision for their own use case. So an example of this kind of workflow we did recently was taking that Oxford Cancer biomarkers use case and making it real for people. So the input data we were using was real-time image stream from a microscope on a real sample of colon tissue, which we were able to get hold of from Oxford Cancer biomarkers very kindly. It's a stained slide as well, so no biohazard stickers necessary. But this was a use case which we tried to create in real time. And if I'm honest, it was a bit of a challenge. We were using, so the microscope was probably not quite poor quality. It was a £300 microscope compared to the £3,000 microscope that Oxford Cancer biomarkers actually uses to label their slides. I think it gave a fun kind of illustration of how this use case kind of worked. So this is an example of the actual the application working. So we've been feeding live image to our model and doing inference in real time. So what I was just doing there was taking the blurred image and then, drum roll, slowly focusing the microscope until it's able to detect all of the cells in the image. However, we found that the inference in this case was very jittery and did require us to kind of write some smoothing functions in the application to kind of have a more level inference. We've also built some demos for clients to help them imagine how they might use AI vision. So this was an example of building a AI system to tell people where in the store they could find certain items. So if they come into a hardware store and they're looking to find a light bulb or where some kind of item is, they can hold it up to the camera and it will then tell them where in the store they could find that item. So this is part of a kind of wider genre of use cases around being able to basically pull up some information on an item that you've identified using a computer vision model. It may seem like a slight overkill kind of case, going into a hardware store and using AI to tell people where items are. But I think that it's useful to just demonstrate what is possible, and then from that, the client might then take that kind of video that we've created, show it to other people, and they may all of a sudden find a use case that fits that in their distribution center or somewhere else. So it's really just about creating that art of the possible to show them how easy it is to integrate this into their workflow.
I can imagine an extension to this where a user at home can take a photograph on a phone, on their phone, and use that to plug into whatever the hardware store's website. And they can show what the item is, whether they've got any stock, and how they can order it, even online, or where it is located in their store, if the person wants to go in and get it from the store.
Yeah, absolutely. And that's the thing, I think, here, that it's we've got so many options for deployment now. This could be deployed, in a browser. It could be deployed on your iPhone. So this could really be done anywhere. And again, it is because we've kind of built this frame. This is just a basic Python Flask application for a different client or a different use case. All we'll do is just change out some of the images that we're using, but it's the same use case underlying it. So it's very useful being able to have this kind of template app that we can basically stick a PowerAI Vision model on a server and just set the whole thing up, and we can kind of port it between use cases to demonstrate what's possible. So I realize I'm running out of time very fast, so I'm just going to race through the final slides I've got. So one use case that was quite interesting was, oh, sorry, I'll skip that one actually. So often when we're at conferences, we want to kind of create some kind of gamified experience to kind of lure people in, and to do that, we could be using PowerAI Vision models, but often to start a conversation about computer vision, we haven't. There's sometimes we haven't actually used the PowerAI Vision model to do that. So IBM Developer makes a lot of their models available online for easy deployment. And there was one model that we were really interested in around pose estimation. So we basically created a very basic Node.js app that uses that model through IBM Developer to basically estimate someone's pose if they're holding a golf club, and then compare them with a famous golfer. So this proved really effective at some of the different conferences we were at this year, such as CogX and Think. As a way of just luring people in, and we can have a talk about computer vision and then kind of segue into PowerAI Vision. Because after all, the image segmentation models that you're training in PowerAI Vision are actually part of the workflow used to train these pose estimation models. And it ends up being quite a fun demo that you can use. So here's some examples of the people that you get matched with. There's cases where people are very happy with who they get matched with based on their pose. And there's other cases where people are frustrated with who they get matched with using this app. So I think that's something that we're always kind of considering, is how we can make these kind of tools fun and engaging at their conferences and in a kind of public setting, to kind of get people interested in thinking about computer vision. So I think that kind of concludes everything I was going to cover here. Just a reminder of my email in case you want to continue the discussion offline. But yeah, thank you everyone for joining. It's been a pleasure, and I'll hand it back over to Jyoti.
Thank you. Thank you, Sean. Yes, reminder, if you do have questions, we'll stay on for a little while. Just post them into the chat window. And while you're thinking of questions, let me just tell you about two things. One is that the PowerVog info page has moved to a new home, and I have been sending information out via various means, emails, tweet and LinkedIn posts. And again, I'll post that into the chat window. So just be aware that there is a new home, update your bookmarks. The second thing I wanted to tell you is that we have a session planned for January the 15th, the next session. And Stuart Cunliffe, who's presented on here before, will be covering a 101 session on containers, Docker, GitHub, Kubernetes, OpenShift, and Cloud Paks, and how they all hang together. What are they and how they hang together, and with a number of demos. So please join us on the 15th of January. It's 2 o'clock UK time. And I'll post information along with the replay of this session. I'll post information about that session. So any questions?
So Jyoti, I might just jump in here and address. So Marvin raised a good point earlier around the PowerAI Vision UI, around, you know, if we're doing auto labeling, can it kind of return to us the images that have been, you know, labeled with little confidence? So I didn't show the example here, but there was a tool that that a team in IBM created to essentially classify thousands of images at one time, and then it would highlight the images that were poorly classified. So this was an application that they built themselves, and it's not currently something that's in PowerAI Vision. However, the developers are really open to where they can improve the UI. So it's something that could be added in the future if we make enough noise. However, I suppose the point being here is that everything you can do in the PowerAI Vision GUI can be done via API. So it's often a case of just finding what you want to do, going through the API docs and writing that into an application. And it's not uncommon for us to write some basic Python scripts or whatever to just automate some of the things that PowerAI Vision doesn't have yet. And this is something that we're looking to make a bit more available for our GitHub accounts. So yeah, always reach out if there's something you think that PowerAI Vision would be better to add, or join the PowerAI Vision Slack channel and suggest it there. They are very active developers, so that they're always on and always provide really good support. So all of these suggestions, I think, should go there.
Excellent. Thank you. I'm going to stop the recording just now and we'll stay on for a couple more minutes. So thank you all for joining.